Here we're asked to solve two exponential equations. One is 27 to the power of x times 9 to the power of 2x minus 1 is equal to 3 to the power of x plus 4. So in the last video we looked at how we could rewrite a bunch of exponents with the same base, and then we could get we could try to rewrite the equation so that the left side is written, the left side and right side are written in the form a to the power of x is equal to a to the power of y. And then we could look at the exponents and we could equate the exponents, saying that x is equal to y, and then we could figure out what values of our variables what values make the left side equivalent to the right side. So, to solve this equation, a logical thing to do would try to be to write all of these powers so that they all have the same base. So 27 to the power of x can be rewritten as 3 to the power of 3x, because 27 is 3 to the power of 3. To the power of x is just 3 to the power of 3x. And I'm going to multiply that by 3 squared to the power of 2x minus 1. Here I've just rewritten 9 as 3 squared. And then on the left side, I've already gotten my power written as base 3. So I can just leave it as, or with a base of 3. So I can leave this as 3 to the power of x plus 4. So now I can go ahead and simplify the second exponent. I've got 3 to the power of x times 3 to the power of, I'll have to multiply the exponents because I'm raising a power to a power, so I multiply the exponents. So I've got 3 to the power of 4x minus 2, and thus that's equal to 3x plus 4. Now I'm multiplying two powers with the same base, so I can add their exponents. So I've got the, oh, whoops, sorry, I'm missing a 3 here. This should be 3 to the power of 3x, not 3 to the power of x. So if I add their exponents, I'm adding 3x plus 4x minus 2, which is 7x minus 2. And that should be equal to 3 to the power of x plus 4. Now that I've gotten this equation written in this form, I can go ahead and I can equate the exponents, because to make this statement true, 7x minus 2 has to be equal to x plus 4 to make the left side equal to the right side. So I have that 7x minus 2 has to be equal to x plus 4. Solve this equation. You get that 6x is equal to 6, and thus x is equal to 1. So the solution to this equation is that x is equal to 1. B is a little bit trickier. Here we've got 9 to the power of y minus 12 times 3 to the power of y, which is equal to minus 27. So this one is definitely a trickier equation to solve. It doesn't mean that it's impossible. It just means that we have to kind of think really hard about what we can do to solve the equation. So a logical thing to do is, here I've got this power written as or with a base of 3. So why not write 9 with a base of 3 as well? And I can rewrite 9 as 3 squared. So 3 squared to the power of y is just 3 to the power of 2y. So here I've got 3 to the power of 2y minus 12 times 3 to the power, times 3 to the power of y, not times 3y, times 3 to the power of y, and that should be equal to minus 27. Now, something to note here is that this, if I rewrite this equation, I can rewrite it as 3 to the power of 2y minus 12 times 3 to the power of y plus 27 is equal to 0. So something to note is that this kind of looks like, first off, it's a trinomial. It's got 1, 2, 3 terms, and if you think about it, this term here, 3 to the power of 2y, is the same thing as 3 to the power of y squared. So here I've got 3 to the y squared minus 12 times 3 to the y plus 27 is equal to 0. What does this look like? It kind of looks like a quadratic equation. So we can try to make a substitution here. We can say let x be equal to 3 to the power of y. And now I can replace, everywhere I had 3 to the power of y, I can replace it with x. So now instead of 3 to the y squared, I'll have x squared. So I have x squared minus 12 times x plus 27 is equal to 0. Now suddenly this is an equation that I know how to solve. I can solve this equation by factoring. So this factors to, well, this is a type 1 trinomial, so I can factor it by saying what two numbers multiply to 27 and add to negative 12, and the answer is minus 3 and minus 9. So I've got two solutions for x. I have that x is equal to positive 9, and x could be equal to positive 3. Now we know that x is just equal to 3 to the power of y. So I can say sub 3 to the power of y for x. So we're just going to substitute 3 to the power of y for x. We're going to replace x with 3 to the power of y. So I've got 3 to the power of y is equal to 9, and 3 to the power of y is equal to 3. So here I've actually got two solutions for y. If 3 to the power of y is 9, well, then 3 to the power of y has to be equal to 3 squared. So one solution is that y is equal to positive 2. If 3 to the power of y is equal to 3, and 3 is the same thing as 3 to the power of 1, then y is equal to 1 is also a solution. So therefore, y is equal to 1 and y is equal to 2 are both solutions.